Hello, friends. Welcome to Block Bytes. The intersection of AI and crypto is a hot topic. This intersection is all about how crypto and AI can benefit from each other. Bittensor is one unique project in this intersection. And today I will talk about yet another exciting project called Jensen. Jensen came into the limelight recently when it secured $43 million in funding led by A16Z. It is a yet to be launched crypto AI project that aims to create an open and decentralized computing infrastructure where developers of machine learning models will have access to the scarcest and the most expensive commodity, GPUs. AI or artificial intelligence relies on something called machine learning. Machine learning allows computer programs to learn rather than being explicitly told what to do, as most programs. These models, as they are called, are first trained on a massive set of data. For example, if you want to create a model that can find cancerous growth by looking at the image of an X-ray of the breast, the training for such a model would require feeding it with thousands and tens of thousands of these X-rays, along with the location of cancer in each. Once the model is trained and then fine-tuned, it is put to use. Using a pre-trained model is called inference. During inference, a model continues to learn and improve itself as it incorporates the feedback received in return for its deduction. This is called reinforcement learning. Both training and inference require hardware, but the requirements are much higher for training. This means that training is significantly more expensive than inference. The training hardware market relies on expensive processors called graphical processing units or GPUs. It is monopolized by manufacturers and cloud providers like NVIDIA, Amazon, Microsoft, and Google. Although GPUs come in all shapes and sizes, the ones used or marketed specifically for machine learning, like NVIDIA's A100, are costly. Meta's large language model, Llama, was trained on $300 million of GPU hardware. An interesting study was done in which it was found that the cost of training models could reach 1% of the US GDP by 2031. Besides NVIDIA, cloud platform providers like Amazon, Microsoft, and Google stand to gain the most. Their high-performance cloud clusters that comprise these A100 GPUs run on a 61% gross margin for Amazon and 72% for Microsoft. All this skews ownership of that sought-after processors in favor of those with deep pockets. This blatantly centralizes the most critical resource for the next generation of Internet of Intelligence. Jensen hopes to change this. Jensen is a layer 1 protocol that combines the unutilized and underutilized GPU power in people's laptops and computers onto one giant decentralized network that can be used to train machine learning models. Such a network will be based on crypto, as it provides an incentive mechanism to attract and keep these people on the network, like Bitcoin and Ethereum. There are several advantages of such a model. Number one, decentralization. The high-performance cluster is not housed in a data center inside the Amazon premises, but over the open internet with people's computers as individual nodes running it. Second, reduced cost. Since the computing capability is spread around hundreds or thousands of individual computers, the cost of running a machine learning model reduces drastically. Now, developers do not need to purchase their own A100s or depend on a heavy profit-making cloud cluster. And third, generalized network. A peer-to-peer network like this does not need to be restricted to a specific type or family of GPUs. It can also include other GPUs, making it more generalized and cost-effective. But this is only half the problem. Assuming that such a network exists, can complex programs like large language models similar to ChatGPT effectively run on it? Let's take Ethereum's network as an example. It currently has over 10,000 nodes with a transaction processing speed of 10 to 12 transactions per second. Jensen discovered that such a network in its current form is unsuitable for performing complex machine learning training, which involves millions of simultaneous transactions and takes days to complete in a fast and centralized data center. So it would be best to have a scaling solution similar to the layer 2s, where most of the execution is done off-chain, like in rollups, but then proved on-chain. This verification process is crucial to the success of the Jensen protocol. With its unique verification process, running on a decentralized peer-to-peer network of nodes, Jensen projects that its hourly cost of machine learning training will be as good as a single GPU in a data center without any overheads, but with the added advantage of scalability. Jensen's light paper mentions that the blockchain will be launched on the Polkadot relay chain. However, in an interview given in November last year, Ben Fielding, one of the founders of the project, said that they are not fully certain if it will be a parachain. But he followed up by saying that from a technology perspective, Substrate came out on top for them as the platform to use. Substrate is an SDK that allows developers to spin their blockchains called parachains that can be easily connected to the Polkadot blockchain. The recent funding raised by Jensen is essentially to create a new team that will accelerate working on building this blockchain. So what is the end game for Jensen? The team believes that Jensen will be the foundational layer for machine learning, just like Ethereum is for smart contracts. It will enable anyone to train machine learning models for any task, similar to Amazon's SageMaker. As a developer, you won't have to worry about hardware and server details anymore. All you have to do is to upload a model and the network will train it. This network could be a single GPU, a cluster, or even hundreds of iPhones. Besides this, the Jensen Foundation will move beyond computing and tackle centralization in data and knowledge, the other two areas currently monopolized by big tech. This will be another project that I will be watching, and if you feel the same way as I do, I'm sure you will too. I hope you like this video. Do like and share, and I will see you next time with another fresh bite. Bye.